Welcome once again. My name is William Sinikweli, who is going to teach P4 class. Remember last time when we met, we looked at reducing fractions to their simplest terms. And we had an activity, and I've picked some few numbers that I'm going to go through with you, and after you check, you even compare other numbers to what I've done here. I remember the first one was 2/6. Do you still remember what we said if we want to reduce 2/6 in its simplest form? We said we shall have 2/6. We look for the number that can divide both of them. Equally, this is what we said, we are finding equivalent fractions by dividing. That's what we mean by reducing fractions. So we say we can divide here by 2. Because we can't use 1, why? It will bring us 2/6 again. You divide by 2 again. So finally this will give us 2 divided by 2. That's somebody saying 1, and 6 divided by 2. This is 3. Very good. Check properly if you got your answer for part A. This was Roman 1, not A. Roman 1 as a third. Okay, try to check Roman 5, whereby we had 16/14. This can happen, whereby even the figure above is bigger than the figure which is below, or the denominator. Somebody has said make it smaller. Still we can find ways of having the number that can divide both. If we try to, what do we come up with? Somebody is saying we shall come up with, this will be 8 and this will be 7. Yes, this is possible. We have made it from the way it is now to be a bit smaller. It can remain like this. You also check Roman 6, whereby we have 4/18. If I have 4/18, this one, if we use 2, how can it be? 4 divided by 2, what do you get? Somebody is saying we shall get 2. What about 18 divided by 2? Somebody saying 9. So do you think we can reduce it more than this? No, we cannot. Observe this one. Lastly, assume you have been given like 18 and it is out of 28. How do you go about this? So if it is 18 out of 28, assume you have started with 2. Where will it go? So this will give you 9, and 28 divided by 2, it will give you 14. We don't have any figure that can divide 9, can also divide 14 at the same time, to go smaller than the way it is. So here it ends there. But I want to remind you before I go to today's lesson that we can reduce the number more than one time depending to how you've used the figures. Allow me to give you this one, like we have 16 and we are dividing it by 30. So if I have 16 out of 30, somebody can apply 2 because it works. So this will give you 8 and this is 15. But do we have this one? Any number that you can divide 8 and 15? No. So what I was trying to mean, we can even reduce the number more than 2 times. You can apply any figure you think can make it smaller than the way it is, okay? Now, for today's lesson, pay attention, and we are not far from equivalent fractions. In this case, we shall see whereby they are giving us equivalent fractions, but some numbers are missing. Finding the missing numbers. But this is under equivalent fractions. Assume our instruction is saying find the missing numbers. Somebody has given you a half is equal to another equivalent fraction that has the numerator is missing and the denominator is 6. How do we find the next number, the next equivalent fraction for a half, but when the denominator is 6? In other words, here they're asking you, what number can you multiply by 2 to get 6? The number we shall multiply by 2 to get 6, it will be the same number we can multiply by 1, and you get what is missing here. Okay? So, how do we know the number that you can multiply by 2 to get 6? Just get 6 divided by 2. What is your answer? Somebody is giving me 3. Very good. Now, this 3 was multiplied by 2 to get 6. So we shall still have a half. We have said we multiplied by 3. What you do in the denominator is what you do in the numerator. Okay? So this will give us, here it has given us 6, as you can observe it. So the missing number, you multiply 1 times 3. What do you get? Somebody is saying 3. Very good. So, now, should we say that this is the number that was missing? Yes, it is observed here. What you multiply in the denominator is what you multiply in the numerator. How did we get 3? We had to compare the denominators here. The denominator is 2. What number do you multiply by 2 to get 6? We've said it is 6 divided by 2. You get 3. So multiply 3 in the numerator and the denominator. It will give us the other next equivalent fraction. And in the next equivalent fraction is where one of them was missing. Hope that one is very easy. That one, very easy. Oh, now look here and we'll look at other equivalent fractions that have missing numbers. Assume you are finding the missing number. This case, somebody is giving us an eighth is equal to the missing number, whereby we are representing the missing number with a box which is very empty. And this is out of somebody saying 16. So what number is missing here? We are looking for the equivalent fraction that is for an eighth. But how do we know the number that you can multiply by 8 to get 16? I've said just get 16 divided by 8. Simply give me the answer over there. 16 divided by 8. Very fast. Very good. So I'm saying 2. Now, if it is 2, that means 2 was multiplied by 8. And when you multiply it in the denominator, likewise, do it in the numerator. Then it will give us the next equivalent fraction, whereby we have said we have a box which was missing here out of 16. So 2 times 8, or 8 times 2, it is 16. Then 1 times 2, somebody is saying 2. So the missing number here is 2. In other words, the next equivalent fraction that we are looking for in this case was 2/16. Okay? Now, let's look at the next example. In this case, you people, I want you to observe very carefully. This is not by guessing. Don't guess to get the right answer. The next we have, this is example part C. We have 5/8 is equal to 20 out of the missing number. I want you to notice the difference between the first two examples and the third one. Do you observe any change? Do you observe any change? The way our question, example A, example B, and now example C. Yeah, not the difference. You'll find that the other time we have been looking for the missing numerator, but now we are looking for the missing denominator. Is it done the same way we have been doing? Yes. There's no big deal here. Now, since we have been looking at the denominators, now let's now find through the numerators now. What number do you multiply by 5 to get 20? That is our question, by the way. Scratch the head and look for it. So here, to get the number that we multiply by 5 to get 20, just to get your 20, you divide it by 5. It will give you the number you are looking for. Somebody saying 4. Very good. So that means this 4 is multiplied by 5. At the same time, you multiply it by 8. So it will be 5 eighths times the 4 we've got times the 4 in the denominator. It will give us the next equivalent fraction. Then 5 times 4, somebody is saying it's 20. This is the one we have. Out of 8 times 4. Scratch the head and give me the answer. 8 times 4. Answer? Very good. Somebody saying 32. So you find that the number we have been looking for, the number we said it has been missing, it has been found. It is no longer missing, by the way. I don't know whether I can delete the other instruction. It is no longer missing, but it is now found. Are you there? So, yeah, we can come back and we fill in the figure that has been missing. Hope you are enjoying this, you people. Should I add you more 1 or more 2? Or I stop here, by the way. Somebody is saying add more 1, which is example D. And sincerely, I will stop on this because this work is so enjoyable. Just deals with the division and multiplication. What it is? We are not adding, we are not subtracting. We are dealing with multiplication and division, okay? My last example in this case is as small as this. We have 2/3 is equal to, we have 8 here, and the denominator in this case is also missing. I want you to compare the first two and these part C and part D. You find that we have been looking for the denominators. Even the last one here, we are looking for the denominator. How do we find this missing number? At this time it is missing, but we are going to look for it. Let's find it. Is it possible? Yes, following what we have been doing. So how do we get the missing number? We look for the number that you can multiply by 2 here to get 8. The number will be the same number we shall multiply by 3 to get what is missing until it is found. So how do we do it? This will be 8 divided by 2. What do you get? Friends over there, what do you get? Oh, very good. I would say 4. What do we do to the 4 here? That means 4 is multiplied by here. At the same time, it is multiplied here. So if I get 2 times 4, and this is 3 times 4, it will give me what is the next mixed equivalent fraction. This is 8, as you have observed it here, out of what you say it is missing. I don't know whether it is still missing. 3 times 4. Give me the answer very fast. Oh, very good. Somebody is saying 12. Should we say that the number is still missing? No, it has been found. It has been found. And after, also come here and put it here. Remember what we said when we talk about equivalent fractions. We mean fraction with the same values. Same values. Members over there, why can't you allow me to end there? Okay? But you see from the start, this is just a walkover. Dealing with the two operations, division and multiplication. Moreover, dealing with simple numbers, which everybody over there is able to divide, to multiply. So from here, I'm just going to give you few numbers that you will take time to write very well and put in these missing numbers. I expect everybody to make sure that at the end of the exercise, all the numbers that have been missing have been found. Are you there? Thank you for listening.